Okay, so how do we go about proving the backwards directions? We want to prove that if a string W is accepted by the DFA, then W is in this language here. That is to say, W is equal to some string alpha with a 0 tacked on the end. So once again, it's a lot easier to prove the contrapositive. So instead of proving this, we'll prove if W is not equal to alpha 0 for some alpha, that implies from the starting state, reading W does not get me to a final state. That is to say, does not get me to S1. Okay? Well, if W is not equal to a string with a 0 on the end, so we're going to assume the left-hand side. So assume W is not equal to alpha 0. Well, if W is not a string with a 0 on the end, what could it be? Well, I guess it could be one or two things, right? So either W is equal to the empty string, because the empty string doesn't have a 0 on the end, or W is equal to some string alpha 1, because obviously this string's got a 1 on the end, right? Where alpha is in sigma star. So this case is easy, right? If we want to prove this, all we have to show is that n star S naught epsilon. Well, if I'm in S naught and I read epsilon, I stay in S naught, and that's not S1. That was easy. Now, how do we prove this case? So what we want to prove is that if W is equal to alpha 1 for some alpha, then we have to show that it's rejected. So we have to show from the starting state, reading W does not get us to S1. Well, if I don't go to S1, the only other state I can go to is S0, right? So basically I have to prove for all strings alpha, from the starting state, reading alpha followed by 1 leaves me in the starting state, right? How do I prove this? Well, this looks very similar to the proof we did before, right? What was the proof we did before? We wanted to prove this property here. We wanted to prove for any string alpha, if I'm in the starting state and I read alpha followed by 0, I end up in the final state S1. Now I have to prove for any string alpha, if I'm in the starting state and I read alpha followed by 1, I end up in the final state. So the proof for this is almost completely identical to the proof for this. You just have to replace the zeros with 1s, but it's the same sort of proof. So I encourage you to do this as an exercise, okay? Because the proof is basically the same as before, so I'm not going to go through it.